Alright, welcome back everyone. This is Shadow Drake, and so this time we're gonna do a demonstration with a stack. So, I had a chip that is already capable of working with this. I'm not gonna go too crazy into the details, but how it works is this dial here is gonna write a value into the stack. This stack pop button will allow us to read a value, and this stack push button will push this dial value into the stack. And now, right now I'm only reading the first 5 indexes on the stack. So what should happen? Since the stack is at 0, this circuit is telling me where the stack is. If I push this 3, it's going to write a 3 in here, and my stack will increment. So just to show it off, boom. There's a 3 in there. It has incremented by 1. So let's just put a 2 in there. Alright, as you can see, I put a 2 in index 1. We're now at 2. Now, for reading, it is this pop. This is going to decrement the stack, and it's going to put whatever pop value in here. So if I were to pop that 2, you see, that 2 came from there, and it's in here. Now my stack pointer is a 1. Now, remember that I said that these values are not affected unless we overwrite them. As you can see, I popped the 2 out from the stack, but it did not clear. So that means that the next value I try to read will be 3 from this pop. As you can see, the 3 came back. Now, if I try to pop again, you're going to see that chip housing error out. And you'll see that it's flashing an error of 15 for stack underflow. And so when I grab this, you'll see that 15 is from the pop, which is underflow. So it's fairly simple code. So now what I want to do is I am going to move to 4. Move the stack pointer to 4, and then I'm going to clear it. So that clear DB will clear this entire stack. And hopefully I should see a 4 here, and that will confirm to me whether the clear actually resets the stack pointer. So as soon as I exported it, all of this cleared, and it looks like my stack pointer is a 4. So that confirms to me that a clear DB will only remove the memory, but not touch the stack. So let me put 511 in here. I'm going ahead and export it, because I will show you that 511 is a valid number. So I'm gonna push that 511. There is no fault. But now my stack pointer is 512. When I push again, there's my error again. Stack overflow, which means that number is invalid for that. So let me just reset that. So we're back at 511. See, let's put a different number. Let's push a 10. So we push the 10, but so 512 will error out if I push again. However, if I pop, you see that I got my 10 back, and we're at 511. So hopefully this is a good demonstration for how the stack works. Let me clear my stack back to 0. Export that back so my stack is back at 0. Alright, so how does this help you? Honestly, because the stack is a memory device, and because it increments and decrements, you can actually push some numbers here, some values that can either be used for setting devices, or what I am about to show you next is actually, I'm going to give you a small teaser. So my stack displayer is actually that second chip, and it is using the get instructions to grab these values. And so one thing that I have done is I did not set any pins for these consoles. I'm going to be using the SBN command. So And one of the things that requires is knowing the exact name of the device you're going to control. So, another method for using the stack would be to do that. You can use your up to 512 memory values to store that many device names, and you could have your IC10 cycle through each of them, controlling all of them. This is going to run into execution time issues without a doubt, depending on the length, but it is possible to control 512 Harveys this way. So, hopefully. So, to recap, pushing to the stack adds a value based on what you have. So, like you have seen, 10, 13, 17, those are values I wrote, and it looks like sometimes my push button pushes twice, so. Then reading, or popping, will read those values back. Ah, I almost forgot one important thing. The peak instruction. So stack tester. Let me go ahead and clear, and let's change this pop to a peak, just to show that off. Alright, so everything's going to clear. We're back at 0. So let's go ahead and push 17. Push a 20. Push a 23. Alright. So my stack is at 3 because it's going to write to index 3. Now remember that I said the peak instruction will read the value without decrementing the stack. So I'm going to read a 23, as we just saw. My stack pointer is still 3. So it doesn't matter how many times I hit peak. It's going to be constantly reading the 23, which is at memory index 2. If I were to then push this 27, now my stack pointer is at 4, and now my peak is going to only read 27. Alright, hopefully this demonstration can shed some light on the stack. Hope to see you then. Next time we're gonna hit LBNs and SBN instructions. See you then.